Hey guys, Mrs. Traver here. We're going to do our notes on section 9.1, quadratic graphs. So before we jump into quadratic graphs, I want to remind ourselves of some stuff about lines. Before we do something unfamiliar, let's remind ourselves of something a little bit more familiar. And let me see if I can get my brightness to go up first. That's a little better. Okay, so linear transformations. Let's look at linear transformations with lines before we do quadratics. So I've got a bunch of things on here that we've seen before. So our first one is y equals x. It is just this basic line, and I did it dashed because it's going to stand out. Notice it's on all of these graphs. We're pretty good at lines. We know that y equals mx plus b. We know what m does, and we know what b does. And so that's just illustrating this. So notice on this one, we went from y equals x to y equals 2x to y equals 1/2 x to show that in comparison to this y equals x function, y equals 2x got steeper, and y equals 1/2 x got more shallow in comparison to that y equals x function. And because we keep referring back to this one, we have a special name for it. It's called the parent function. So the function that has nothing for m, or I should say 1, and has nothing for b, or I should say 0, that's the parent function. So we'll deal with that. That'll come up later. We also know what b does. So if we looked at b being 2, notice it just went up 2. If it was negative 3, it went down 3. And if it was negative, it reflected across the axis. So it got flipped. So we've got up, down, and reflected. So that's how our videos will treat us. Let's look at quadratics now that we reminded ourselves of that. So quadratic standard form is one that we're kind of familiar with already. It is ax squared plus bx plus c. So this a, b, and c we're going to deal with over the next few videos of notes. The parent function for our quadratic function is when a is 1 and b and c are 0. So that is y equals x squared. So before we do anything else, let's graph and get to know our parent function. So let's check this guy out. Y equals x squared. What we'll do first is get ourselves some points. It would be good if we grab some negatives and positives. I'm going to use -2, -1, 0, 1, 2. And then I'll plug each of those in for x. So if, let's start with the positives. Those ones are nice. If I plug in a 2, I've got y equals 2 squared. That's 4. So we're at the point 2, 4. If I plug in 1, I've got 1 squared. That's 1. So that's the point 1, 1. If I plug in 0, I've got 0 squared. That's the point 0, 0. And if I plug in -1, be careful on these ones. If I plug in a -1, I've got y equals -1 quantity squared, which is -1 times -1, which is +1. Notice that parentheses definitely matters. So this will give us a +1 for the point -1, +1. And lastly, if I have y equals -2 quantity squared, again, be careful with the parentheses. -2 times -2 is +4. So I've got a point here as well. So I've got all my points. Do not connect these to make them look like a V. It is a curve. I'm kind of picky about that. So give it a little curve. And then extend your lines to the edge of the graph. So keep going in the way it's going. Like so. So there's our parent function. Let's talk about this function a little bit with some words we'll use. Our vertex, in this case, is at 0, 0, but that vertex is what we're going to end out later calling HK. I just want to kind of show that to you ahead of the time. But the vertex is the turning point of the graph. All right, and then the vertex in this case can either be a maximum or a minimum. So if it's the maximum, the vertex is the highest. So if it was the highest point, it would be like this, with the vertex at the very top. If it's a minimum, the vertex was the lowest. That's like the one we have, where it's like this, and our vertex is down there at the bottom. Lastly, we have this axis of symmetry. So I kind of mentioned axis of symmetry up here with the reflection. It also comes into play down here when we do our axis of symmetry. So if you could fold your paper somewhere, you could fold it right here on this axis, and it would make the same graph. So our axis of symmetry um, is the reflection line of the quadratic curve. And I'm just going to write to be continued for that part because we're going to come back to axis symmetry when we learn later about B, so we can find out how to exactly find what that line is. All right, so let's look at what's next. This next is just some recall on the vertex. So it says identify the vertex of each graph, tell whether it's a max or a min. So here's our vertex right at the bottom. It's bolded in nice and pretty for us. It is, notice your axes are counting by 2, so it is, oh, here's 4, so that means that's 2. These are counting by 1, so sorry. So it's at 1, -3. And it's at the bottom, so it's a min. And this next one, it's also a min. This one is at 1, 2, 3, -1. And it's also a minimum because it's the lowest point on the graph. The next one is 1, 1, 2, 3, 4, 5, 1, 5, and it's at the very top, so it's a max. All right, let's do our next set. So we've got some graphs here. Notice I drew some in there already for you. So just like we did, let me actually rewind. Just like I did with these linear transformations, notice dashed in was our parent function y equals x each time. And that way we could refer and say steeper or more shallow or up or down or reflected. We could compare and contrast. So the same thing I'm going to do here. Our parent function I already drew for us, and that parent is there, y equals x squared. So looking at the first one, y equals 3x squared. Let me go up here. Messing with my light the whole video, I apologize. Y equals 3x squared. So let's use some points to plug in. Again, let's do the same ones we had before will be fine. -2, -1, 0, 1, 2. It's nice to have some to the left, some to the right. And then each time we're just going to plug numbers in. I like to start with the positives. So plugging in 2, I'd have 3 times 2 squared. That's 3 times 4, so that's 12. 2, 12. My next one, if I plug in a 1, I've got 3 times 1 squared. That's 3 times 1. That's 3. So 1, 3. Next one, if I plug in a 0, I've got 3 times 0 squared. That's just 0. And then I want you to notice that because we have a reflection, these are just going to get reflected over as well. So I know this point is also going to be over here on the other side of the line, and this point is going to be over here on the other side of the line. And I got those because this 3 will be here as well, and here as well. So I know I can fill in a 3 and a 12 because of that reflection. So you don't actually have to find that many points in your table, just to be clever about them. So let's figure out what happened here with 3. It looks like it got skinnier. So this A being 3 made our graph skinnier. All right, so that 3 made it skinnier. Let's look at what 1/3 does. Well, if 3 makes it skinnier, you might have a guess on what 1/3 does. Let's see what happens. We're going to use those same points, -2, -1, 0, 1, 2, and plug in. I like to start with positives, so if I plug in a 2, I've got 1/3 times 2 squared, so that's 1/3 times 4, so that's 4/3. 4/3 is a weird one to graph. Let's make it be a mixed number, 1 1/3. So 2, 1 1/3. If I plug in a 1, I've got 1/3 times 1 squared. 1 squared is 1, so that's just 1/3. 1, 1/3. If I plug in a 0, I've got 1/3 times 0 squared. That's just 0. And then again, because of my reflection, I know that this point will go here. This point will go here around that 0, 0 point. So I know my next 2 points will be here and here. Oh my gosh, I put them in the wrong spots. How embarrassing. There we go, more like that. So there's our points. If we connect just those ones, it's really not enough. So carry it on out. And we can see this got wider. Or as my kid said, fatter. But I'm going to go with wider. Okay, so we're noticing if A is a number, it's skinnier. If it's a fraction, less than 1, it's wider. Let's see what happens if it's negative. So notice my axis changed a little bit. It's almost like I know what's going to happen here. Let's plug in those points we've been using, -2, -1, 0, 1, 2. If I start with my positives, if I plug in a 2, I've got -2 squared. So that's 2 times 2 is 4, and then make it negative. So 2, -4. If I plug in a 1, I've got 1 times 1 is 1, and then throw a negative on, you get a -1. So 1, -1. If I plug in a 0, I've got 0 times 0 is 0. -0 is just 0. So there's your point there. And then again, our reflection will happen. So I know there'll be a -1 and a -4, and I can just throw in those points. So let's see what happened. This one got reflected from here's our top one. Notice it keeps going on and up, and it got flipped. So it got reflected or flipped. That's the mathy way to say it. That's the other way to say it. Let's do one more. So this one, since we already kind of know what's happening, notice number 7 is like a combination of 6 and 4. So 4 was 3x squared, 6 was -x squared. We could take a guess that this should be skinnier and reflected, and that's going to be what will happen here. So this should be skinnier because of the 3, and this should also reflect because of the negative. So both things will happen here. Let's show it. So if I plug in a 2, I've got 2 times 2 is 4, times -3 is -12. If I plug in a 1, I've got 1 times 1 is 1, times -3 is -3. If I plug in a 0, I've got 0 times 0 is 0, times -3 is 0. And then I know enough to make my crossovers. And let's plot our points. So -2, -12. -1, -3. 0, 0. 1, 3. And 2, -12. So we've got them all. And it's exactly what we would have expected. It is skinny and it is reflective. Let's look at the last one. So these ones ask us to write the graph in order from narrowest to widest. So what we've learned here is that the narrower they are, the skinnier they are, the higher the A value. And the wider they are, the lower the A value in between 0 and 1. So looking at these ones, we've got 0.4, 5, 4, and 1/5 to compare. It'd be nice if they were all in a standard form. Notice there's some that are decimals, some whole numbers, and some fractions. So let's maybe choose to make these both be decimals or both be fractions. I would prefer fractions, I would prefer decimals. So 1/5 as a decimal is 2/10, so it is 0.2. So this is the same as 0.2x squared. So let's see, if I was going to rank these from the most narrow, that'd be the highest A. So this would be the most narrow, number 1. Number 2 will be the 4. And then these ones, the biggest one would be 0.4. So then this will be next. And then 4th place, g of x. So biggest number to smallest number. Let's look at the next ones. Write the graphs in order from narrowest to widest. And notice this one, there's a couple negatives that are thrown into us. Because we're just talking narrow or wide, we don't really care about if it was reflected or not. So we can kind of just ignore that. So I've got a normal number that's a 1 out front hiding there. -0.4 and 1/4. 1/4 is 0.25. So let's rewrite this guy as 0.25 x squared, and then we'll be able to rank them. So biggest number you see, regardless of the negative, is here. So that's first place. Next biggest number would be the 1, second place. The next biggest number would be the 0.4, ignoring the negative, third place. And then last place, so sorry g of x, last place again. All right, call it a day on these notes. I will see you guys next time.